Hey, what's up, guys? This is Chung here. So let's take a look at last problem of this week's weekly contest, which is number 1675. Minimize deviation in array. It's very interesting. I would say it's a math related problem. Basically, you're given like an array nums of n positive integers, right? And then for each of the integers, you can perform any of those two operations. If the element is even, you can divide it by 2. If the element is odd, you can multiply it by 2. And then the deviation is the array. Basically, the deviation is the maximum difference between any two elements in this array. Basically, the deviation is the difference between the maximum number and the smallest number in this array after these operations. And it asks you to return the minimum deviation, right? Minimum deviation among all those kind of results, right? So, and here are some examples here. So let's say we have 1, 2, 3, 4, and as you guys can see, so the current deviation for this one is 3, right? Which is 4 minus 1 is 3. But if we divide 4 by 2, then we have 1, 2, 3, 3, 2, right? Then the deviation is what? Is 2. But then we can continue increase increase I by basically double multiply 2 with this 1 here, which we have 2, 2, 3, 2. Then finally we have our final answer, which is 3 minus 2 is 1. So that's the first examples. And similar for this second examples here, right? Basically we increase this 1 to 2 and we decrease this 20 to 5, right? And then the final answer is 3. So for this problem, since we have two ways, so if you make some observations, right? Basically, if this number is even, it means that it cannot be increased anymore. So because an even number can only be divided by 2, which means the uneven number can only become smaller. Same thing for the odd number. So an odd number cannot become smaller. It can only become uh, greater by multiplying with 2, right? So, and since we have these two options, it's gonna be hard for us to maintain these two options at the same time, right? Operations at the same time. So the way we're solving this problem is that we have to fix one of one of those conditions, and then we'll either we'll either through we'll try to, let's say, if we fix the max size, and then we'll basically we'll try to decrease the uh, the maximum values, right? And then if we fix the the smallest values, and then we'll try to increase the smallest values. Either way is fine. So and the way I'm doing here is I'm going to maintain like a priority queue, which will stores which will maintain the maximum value, and then I do it by convert each number to its biggest numbers first. So which means that, if this number is a even numbers, then it's already at its maximum values, then I'll just simply insert into that priority queue. But if this is odd numbers, as I can just so with this number, the maximum number for this odd number will be an odd number times 2. That's going to be the maximum value for this number. right? And then I do this after the first for loop here. I have a priority queue with with all the biggest numbers for each of the digits, right? And then from here I'll try to basically decrease the maximum numbers from this priority queue, right, by half while maintaining the minimum number as well. And then when we then what's gonna be the exit point, which means that we're trying to we keep decreasing the maximum values by getting the current maximum value from this priority queue, right? And then let's say if the current biggest number from this priority queue is a even numbers, and then we know, okay, so we can simply do a divided by 2 because we know we can decrease, we can change the current maximum values by divide this current maximum value by 2, and then we'll push the new value back to the priority queue. But if the current max number from the priority queue is even numbers, let's say if it is 7, then we know, okay, so there's no way we can decrease 7 because for if it's 7, we can only multiply by 2. Then we can simply break the while loop. But if this is 6, and then we can simply divide it by 3, and then we will just divide it by 2. Now we have 3, and then we'll push the 3 back to the priority queue. And every time when we have a new numbers here, we'll also like update the minimum values because that's how we get the current deviation of the array. So mm, I know I don't know if I explains clear enough, but maybe I'll try to explain a little bit more. So like I said, the priority queue here, right? I'm maintaining like the current maximum numbers, the current max numbers for this array, right? I'm using the priority queue because that's the priority queue will only take a log n time to update the current max number, right? So I also need to maintain like the minimum numbers, right? So for the minimum numbers, I'm just going to use like system. I'm just going to use the variables to maintain that. So at the beginnings, I'm going to convert each of the digits number to its biggest possible values, and then I'll push it into the priority queue so that I'm sure I have I have the maximum values for all the possible numbers by doing these two kind of operations, and from there I can just safely try to decrease that max numbers, and then while maintaining the deviations, right? The minimum number and plus the deviation. So in nums, so if the num divided by 2 equals to 0, which means it's even numbers, then we can simply I'll just do a heap q dot heap push, right, priority queue, and then I'll just simply push this number because I know that's gonna be the answer. That's gonna be the max value for this num. And then I also maintain this minimum numbers. Mm, the minimum dot num, right? Else, right? Else it's a odd number, which means we need to multiply the number by 2. Heap push dot priority queue dot num times 2. Oh, by the way, sorry. So since I need the maximum value from this priority queue, but in Python, this priority queue by default it only can give us the minimum numbers. That's why I need to do a minus. I need to reverse the signal the sign for this number so that the priority queue will give us the biggest number, right? Same thing for this thing. I'm also going to maintain the minimum dot, now the number is num times 2, right? That's gonna be the, so now after this, after the this first while loop here, the priority queue 0, right? The priority queue 0 and the minus, right? Of course, minus priority queue 0 will be the the, the biggest, the biggest possible numbers, right? For this nums here. And then all we need to do is that we will just try to decrease that number, right? One by one. So I'm going to have answer equals to the system dot max size, and then the while the priority queue is not empty, right? We have current. So the current is what is the minus the heap queue dot heap pop, right? Because this is going to be the current max numbers, and then I will do a minus, right? So every time when we pop that out, right, we'll update the answer, right? Answer dot is going to be the minimum of the answer dot current minus the minimum, right? This is the current, our current deviation, because the current one is the current maximum and the minimum, of course, is the current minimum. And then if the current divided by 2 is not empty, right? It's not 0, then we know that the current is an odd number. Odd number means that there's no way we can continue, we can decrease our the current max number anymore, right? And then we can simply do a break here. Otherwise we push that back, right? Heap push dot priority queue, and then we do a minus current divided by 2, right? And then after that, we don't forget to update minimum, right? Minimum is the minimum dot minimum current divided by 2, right? And then in the end, we simply return the answer. Right, so if I run the code, did I, oh, here, okay, if I submit, yeah, okay, so it's passed, right? So how about the time complexity, right? So the time complexity, I think for this part is pretty straightforward. That's just O of n, so we can ignore this part. So the most significant running time is right here. I mean so the way we're defining this, we're calculating this thing is like this. Let's say we have n here, right? So n is the length of nums here. N is the length of nums, and since we're doing like this current by 2, right? Let's say the max n is m is max of the numbers, right? So how many, I mean, how many numbers we will be there will be putting into the priority queue? So we will have at most we'll have like uh so for each number, so anyway, so the worst case scenario, each number will be put into this priority queue one time, right? And for each numbers we have n here, right? And each number it will be decreased, I mean, by half, and then it will basically push back to this priority queue again. So that's gonna be what? N times log m, right? So that's the total numbers, the total number of elements we will be pushing back, will be pushed into this priority queue, because we have n numbers, and each number can have up to log m, I mean new push, right? And then the last one is what? The last one is the within the while loop we have like the heap pop and heap push, right? And each of these will take what? Will take log n time, right? Because the worst case scenario we will have n in this priority queue, and then the heap pop and heap push will both take log n. So that's why the total time complexity is this. It's n times log m times log n, right? And the space is what? Space is just the O of n, because we will just have this priority queue which will take like at most on space. Mm. Yeah, I think that's it. I mean, I think this problem is pretty tricky because the you have to find out the how can you fix one side basically, right? You have to fix either the minimum possible values for all those numbers or the maximum possible values of for all those numbers. In this case, I use the maximum possible numbers. And then once you have that one, you can try to decrease. You can try to decrease that max numbers one by one, right? While maintaining the minimum number along the way by using a priority queue. Uh, yeah, I think that's it for this problem. And thank you so much for watching this video, guys. And stay tuned. See you guys soon. Bye bye.